happens when something is in equilibrium, there is no apparent change. And since there will be no apparent change, the E cell, the EMF of the cell will be equal to 0. So our next equation, it says that we have E cell is equal to E naught minus 0.059 divided by the number of electrons log of product upon reactant, raised to the power that. Now, since E cell is equal to 0, then we can write E naught is equal to, this is 0, this minus 0.059 will go there, that side, and it will become E naught is equal to 0.059 divided by N log of product upon reactant. Okay, so please try this now. Once you, and also one more thing, at equilibrium, this product upon reactant, it is equal to what? It is equal to the equilibrium constant K. We have this equation. Now here you have to, if the equilibrium constant is the value of X. Now try this question. You have to tell the power of 10. Log K will be equal to N E naught upon 0.059. Okay, you calculate this. You calculate the E naught from here. Take one more minute. Okay, 39. What is the E naught, guys? Tell me. आप लोग को E naught क्या मिला? MnO4 negative. It is getting converted to Mn2 positive. That means what is happening to this Mn? Manganese, it is getting reduced, right? So reduction is happening here. And for oxalic acid, there will be oxidation. So reduction 1.51 plus 0.49. So this will be equal to 2. 2 volts, 3 volts, 33. Okay, fine. So number of electrons Okay, now tell me guys, what will be the number of electrons? How much electrons? How many electrons did you guys take? 2. Why 2? 10. Why 10? I mean, whatever it is. See here you have to see the change in oxidation state. Now, so Mn, it is in +7 oxidation state and it is going to +2 oxidation state, right? So there will be 5 electrons. Yes. And right, 5 multiplied by E naught, that is 2 divided by 0.059. So this will be equal to 5 to the 10 upon 0.059. So approximately this will be, if I take 0.06, your 169 is coming as the answer, 169.4. By the way, is 5 electrons, we have to check for 5 electrons. Huh? Just give me a second. MnO4 negative, it is getting converted to Mn2 positive. That means this will require 7 electrons, sorry, 5 electrons. And then we have C2O4H2. So this will be requiring how many electrons? Carbon 4, 2x minus 8 is equal to 0. So 2x is equal to 8 minus 2, x is equal to 6 by 2, that is equal to 3. So x is equal to 3 here, and here x is equal to 4 plus 4. Here H plus, here it is also H plus. Yeah, they are saying 10 electrons. 5 only, I think. Plus 2x. Yeah, am I audible? Hello, yeah. See, 5 electrons will be there. I think, let me just recheck this. H plus is still H plus here. There's no change in H plus. Maybe I'm wrong. Okay. But H2CO, C2O4 is minus 8. 8 will go that side. 8 minus 2, x is equal to 3. Yeah, 5 electrons will only be there. Okay. And is this balanced? Let me see if it is balanced or not. And one manganese, and here also we have one manganese. Okay, this equation is not balanced. Here you'll have to put 2. No, fine. Yeah, I think there will be 10 electrons because the equation is not balanced, right? So if you look at H2C2O4, H2C2O4, it will give CO2, right? Now C2 is what? +3, and carbon dioxide, this is +4. Now, but here, if you see it, there are 2 carbon atoms. So here also you'll have to put 2. So if I want to go from +3 to +4, we need 1 electron. But since there are 2 carbon atoms that are undergoing this oxidation, we'll be requiring 2 electrons. And when we have to balance this, we will have to multiply 2 here. And in this equation, we will have to multiply 5 in order to balance the number of electrons. So here there will be 10 electrons. Correct. This will be 10 electrons. So if we are doubling this, then double of 169 will be how much? 300, 319, 38. 338. This will be correct. Okay, so please check this part. Balancing of the reaction. Maria, just I think this was not correct for you. That is why you were getting 159, 169, I guess. After that, we have to do the KSP one. Done, everyone? Anyone still writing? No, no one is writing. Actually, you have the other question. At 298 Kelvin, the standard. Done. Okay. At 298 Kelvin, the standard reduction potential of copper 2 plus to copper electrode is 0.34 volts. Given KSP of copper hydroxide is 10 to the power minus 20. Take 2.303 RT upon F as 0.059. The reduction potential at pH 14 for the above couple is minus X into 10 to the power minus 2. Now, what is solubility product? Solubility product is copper OH whole twice. It will dissociate into copper 2 positive plus 2 OH negative. Okay. So solubility product says that the concentration of this and the concentration of OHs. These are the products of copper hydroxide when it dissociates, and their solubilities, that means their concentration, उसी को क्या बोलते हैं? Solubility product. So concentration of copper 2 positive and concentration of OH negative squared will be equal to the KSP. Now, from here you can calculate the concentration of copper 2 positive. How? See, how many copper positive we are having? 1. And how many OH negative we are having? We are having twice that much. So we see here, we can say that this copper 2 positive and this OH negative, they will be having the same concentration, but this will be X. And how much OH negative we are getting? We are getting 2 times of the copper. So we'll write 2X and this will be squared. This is KSP. And once you calculate X here, that is equal to 4X cube is equal to KSP. And X will be equal to the KSP divided by 4 and the cube root of it. Now, if you see what is the KSP, KSP is 10 to the power minus 20 divided by 4 and then its cube root. So from here you will get the X, and what is X? X is the concentration of copper 2 positive. Okay, so please calculate this part, X part. KSP is given, and then they're saying the reduction potential at pH 14. Acha, एक second. So if pH 14 is given, na, then it will become very easy for you guys. Just a second, guys. You will not have to do all these calculations. If pH 14 is given, from pH 14 you can calculate what is the concentration of H plus and OH negative also, right? So at pH 14, the concentration of OH negative will be equal to 1 molar. ठीक है, इसको आप करके देख लीजिएगा. That at this case, the concentration of H positive will be how much? 10 to the power minus 14. And we know that the concentration of H plus multiplied by the concentration of OH negative will be equal to how much? 10 to the power minus 14. Okay, this is from the KW. the dissociation constant of water. H plus into OH negative will always be equal to 10 to the power minus 14. H plus is 10 to the power minus 14. That is why OH will be how much? OH will be 1. So from here, you can directly calculate the concentration of Cu2 positive. This will be equal to how much? 10 to the power, because OH negative concentration is 1. So 1 square will be 1. So concentration of Cu2 positive will be 10 to the power minus 20 itself. Okay? At pH 14. So you have got the concentration of Cu2 positive. Then they are saying the reduction potential for the above couple. Couple is this couple, copper 2 positive to copper. That means copper 2 positive plus 2 electrons give copper. Now you will have to put the E is equal to E naught minus 0.059 divided by 2 log of copper. Copper is solid, so I will take it as 1 divided by copper 2 positive. Now you calculate this term. E naught is 0.34. You will have to put copper 2 positive as 10 to the power minus 20. And then calculate. Ten to the power minus 20, it will go above and become 10 to the power 20. Right? This will be 0.34 minus 0.059 divided by 2 into 20, I guess, right? Minus 0. This is 0.059. This will be how much? 34 में कितना ऐड करेंगे? 5 and 2 minus 0.25 volts. ठीक है? So minus x. So x will be equal to how much? 25. Done everyone? Yes or no, please tell me. Anyone still writing?
Yes, certain.
But we have done no already. चलिए try this. Please see that which of the following is not correct. By the way, envisaged matlab it can be imagined as, है ना? So instead of envisaged, you can write imagined. Okay. The rusting of iron is like electrochemicals setting up an electrochemical cell on the surface of iron object. Okay. So basically, this statement is saying that rusting of iron is electrochemical process, है ना? और electrochemical reaction. ठीक है? Dissolved acid oxidizes SO2 and NO2 in water, acts as catalyst. Huh? Basically, it is saying that acidic, if you are having acidic medium, then it is going to act as a catalyst for the process of rusting. Then it is saying coating of iron surface by tin prevents rusting, even if the tin coating is peeled off. Then it is saying when pH lies above 9 or 10, rusting of iron does not take place. So I have not got any answers. चलिए ठीक है. What about the first statement, guys? Tell me, true or false? क्या ख्याल है आप लोगों का? Is rusting of iron an electrochemical is like an electrochemical reaction, electrochemical process? Yes or no? True or false? बताएं. This is true, right? The first statement. I hope because आप लोगों ने rusting of iron, you must have studied in this particular chapter itself, right? Electrochemistry. So we can say that it is an electrochemical reaction. This is true. ठीक है. Now let us suppose you don't know about B, C, and D. But if you look at the statements of B and D, see, it is saying when it is acidic, then it is acting as a catalyst. And when pH lies above 9 or 10, that means when it is basic, the rusting of iron does not take place. So if B is true, B should also be true. Make sense? If B is true, B should also be true. Yes or no? Guys, tell me. क्या ख्याल है? Does this make sense? In acidic conditions, it is what? It is facilitating the rusting process. And in basic, it is hindering. That is why rusting does not take place. ठीक है. And if B is false, D should also be false, but it cannot happen. We cannot have two options which are incorrect because we have to choose one option. So we are only left with which one? We are only left with option number C. That this is incorrect. See, if B is incorrect now, if in acidic condition it is not acting as a catalyst, then in basic condition, acidic condition it is not acting as a catalyst. Then in basic condition, it should not. I mean, it should rust. So if B is true, D should also be true, and if B is false, D should also be false, and that cannot happen. We cannot have two incorrect statements. The C statement is correct, and there is also one thing that tin and zinc. These are the two things which are used for the prevention of rusting, and zinc is preferred. Why? Because if you look at zinc, if you guys know the electrochemical series now, so where do we have the electrochemical series, iron and everything? लेके बाद ताना मजे से आया, कोई नहीं जाने. लेके बाद ताना मजे से आया, मंजन कर फेंक दे, मंजन कर फेंक दे. And then we have कोई, then we have कोई निगाहें सुंदरी carefree. ठीक है. So if you see here, zinc is before iron and tin is after iron. So it is fine if you cover the iron surface with tin. Iron is not exposed to the atmosphere. So in that sense, it is going to prevent it. But if the tin is what? If the tin is peeled off and it is scratched and the iron surface is now exposed to the atmosphere, it will start rusting. So tin can only prevent by stopping the atmosphere to interact with iron. But if we are going to place zinc with iron, then what will happen? Even if the zinc layer is peeled off or it is scratched and the iron surface is visible now and it is in contact with atmosphere, but still zinc will be rusting and iron will not be rusting. Why? Because zinc has higher reduction potential. Zinc has not higher reduction potential, but rather a lower reduction potential and higher oxidation potential. And we know that rusting is an oxidation process. Iron को iron के oxide में change कर देता है. Fine. So since zinc is having higher oxidation potential, it will be preferred for oxidation rather than Fe. Okay, so you can also remember this, that zinc is better than tin. Fine. Please write this down. Done, guys? Anyone still writing? Anyone still writing?
No, sir.
Moving on. Can you try this? What is brine? Do you guys know what is brine? Brine. 10th class में है brine. Yes, correct, Maria. Brine is aqueous NaOH. Sorry, my bad. Aqueous NaCl, not NaOH. Aqueous NaCl solution, not NaOH, Maria. NaCl, salt solution. This is factual, completely factual. बहुत सारा डी का रहा है. चलिए. ठीक है, देखिए. So NaCl, we have Na positive, and this, what can happen? We can put one electron and it will become sodium. So we have sodium positive plus 1 electron gives sodium, or we can have H positive from water. It requires 1 electron and it will give you H2. Both of these reactions are what? Both of these reactions are reduction. That is why they can occur on what? They can occur at only anode. Sorry, cathode. Okay. So Na plus is there? No, Na plus is not. Na is not there anywhere. But they are saying something about H2. H2 is formed at anode, so this is not right. This is incorrect. Now, in the anode, we can have two things. Either Cl negative will lose electron and it will form Cl2, or what could happen? Or you will have OH negative, which will be formed as O2. Both of these can happen at anode. Okay. So Cl negative and OH negative O2 can be formed, but because O2 is going to have a very high over potential, O2 is not formed. Cl2 is formed at anode. So Cl2 at this is not, this is incorrect. O2 is formed at cathode. This is also incorrect. So the only correct statement that we can have is OH negative. It is formed at what? Anode, because it cannot form O2 because of the over potential. So OH negative is formed at cathode, they are saying, but we have H2O, OH negative at cathode. Just give me a second. इसमें कोई सही नहीं है क्या? O2 at this is cathode में sodium and hydrogen only can be formed. Cathode and cathode. Cl2 at cathode. No, Cl2 at anode. So OH negative at cathode. OH negative at cathode, it can be formed if you have NaOH. In NaOH, Na positive plus OH negative. Na positive will be at anode and OH negative will be at cathode. So in that sense, we can say that OH negative is formed at cathode. Yes, the B option will be correct then, because all of these statements are incorrect. Let's try next one. Now, for this type of questions, now in Faraday's law, they're asking about the coulomb of electricity required. You have to remember one formula. First is coulomb. It is equal to ampere into seconds. If they're asking in terms of the electricity and the time through which in which the electricity is flowing, then you can use this formula. The ampere it is equal to, this is actually Q is equal to IT. Okay. But I'm writing it in the terms of units also. Coulomb it is equal to ampere into seconds. The other formula that you have to use is Faraday it is equal to number of moles into delta OS. Now you will use this formula whenever there is a reaction. Okay. And you will use this formula whenever there is electricity, that is I and time are involved, then you are going to use this formula. In order to convert from Faraday to Coulomb, then you should know that 1 Faraday it is equal to 96500 coulombs. Here they are asking the amount of electricity in Coulomb required for the oxidation of 1 mole of H2O to O2. So this is pertaining to reaction. So you'll use this formula, you will get the Faraday, then you will convert it to coulombs. So now H2O to O2. So from this reaction, you have to only look at the change in the oxidation state. So oxygen is -2 here, and here the oxygen is what? 0. So delta OS is equal to how much? It is equal to 2. And how many moles of H2O we are having? We are having 1 mole of H2. So the Faraday will be equal to how much? It will be equal to 1 mole into 2. That is equal to 2 Faraday. And 2 Faraday is equal to 2 into 96500. Now multiply this number and you will get the answer. ठीक है, इन दोनों को लिख लीजिएगा. C is equal to A into S and F is equal to into delta OS. What's the value you are getting for this? 96500 into 2. Is that 10? 1, 6 to the 12, 13, 9 to the 18 and 19. And then 2 more zeros. And 10 to the power 5. So 1, 2, 3, 4, 5. So this will be equal to 1.93 into 10 to the power minus 10 to the power 5. This will be equal to 2 will be the answer. Yes, Shahid, Tarif, you are fine. So answer will be 2 because you have to put it in 10 to the power 5. Make sense, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Anyone still writing? Anyone still writing? No one is writing. Now try this. 1 Faraday of electricity liberates itna gram atom of copper from copper sulfate. X is equal to how much? 1 Faraday electricity. So here you will have to mix things. So copper sulfate is what? Cu, SO4 to copper. So here you are having +2 oxidation state and here you are having 0. So delta OS, it is equal to how much? 2. So you can say that if I'm assuming it to be 1 mole, if I'm assuming it to be 1 mole, then I can say that Faraday is equal to N into delta OS. So 2 Faraday, then it will be giving you 1 mole into delta OS is equal to how much? 2. So 2 Faraday will be giving you 1 mole of copper, we can say. 2 Faraday gives 1 mole of copper. Now 1 Faraday gives 0.5 mole of copper. So they are saying 10 to the power minus 1. That means 5 into 10 to the power minus 1 will be the answer. So x will be equal to how much? X will be equal to 5. If you look at this equation, from here we can say that you need 2 electrons. That means 2 moles of electrons means 2 Faraday. 2 Faraday is going to give you how much? How many copper we are getting? We are getting 1 mole of copper. So 1 Faraday, they are saying 1 Faraday of electricity will give how many gram atom of copper? So it will be 5. ग्राम एटम का मतलब मोल होता है भाई, ठीक है? Still writing? Writing down. Try this. The mass of silver displaced by a quantity of electricity which displaces 5600 ml of O2 at STP will be dash grams. So here they are saying that you have to first of all calculate the amount of electricity that is displacing this many ml of O2 at STP. And once you get that amount of electricity, you will have to apply it to what mass of silver it will be displacing. Okay. First of all, calculate this, how many moles we are having. 5600 ml of O2, that means how many? 5.6 upon 22.4 liters, right? This will give you how many moles? I think 1/4 will be the answer. Okay, so you have got 0.25 moles of oxygen. They're asking the mass of silver displaced by quantity. So mass of silver displaced, that means what equation you have to make? You have to make Ag. Generally, the common oxidation state of Ag is Ag positive. It will require one electron to give you Ag. So this is the reaction that is happening here. So what is the reaction that will be happening for the case of O2? So O2, it is generally prepared from water. So H2O will give you O2 plus 4H positive and 4 electrons once you balance this. So in this case, the number of electrons required is how much? It is equal to 4. So you can see that here we are getting 1 mole of oxygen, 1 mole of O2 needs 4 moles of electron. That is why you can say 1 by 4 mole of O2 needs 1 mole of electron. And if we are using this 1 mole of electron here, then we will be getting how many? We'll be getting 1 mole of Ag. See, the question is saying that we need the amount of electricity which displaces 5.6 ml of O2. What is 5.6 ml of O2? It is 1 by 4 moles. Okay. Now, what is the amount of electricity required to displace or to get 1 mole of O2 according to this reaction is we need 4 moles of electron. And if we want only 1 by 4 moles of O2, then we will need only 1 mole of electron. That means this many moles of electrons was given by the electricity which is displacing 5.6 liters of O2. So we had this many moles of electron from the electricity. And if we are using this many moles of electron in order to displace Ag, we will be getting 1 mole of Ag. And 1 mole of Ag, the mass of 1 mole of Ag will be equal to 108. Okay, so the answer will be 108. Please copy this down. Yeah, the things that are not clear are the, okay. So generics equations यहाँ पे लिया जाता है. You will understand this only when you are going through questions.
Can you explain this once more?
Yes, okay. So from the starting I'm explaining. Okay, Tarif, you just let me know if you are following. First of all, we will have to calculate the amount of electricity or the number of electrons that is displacing 5.6 liters of O2, because we are using that same amount of electrons for displacing silver. Does this make sense?
Yes, sir.
That we have to calculate this part. Okay. Now, in order to calculate
Yes,
this,
sir.
first of all, we will convert this thing into moles. So 5.6 liters is equal to 1 by 4 moles. And according to this equation, H2O gives 1 mole of O2 and it requires 4 moles of electron. So 1 mole of O2 needs 4 moles of electron. But how much moles of oxygen we are getting? We are only getting 1 by 4 moles. So for 1 by 4 moles of O2, we will require, see, 1 mole require 4. So 1 by 4 will be requiring how much? It will be requiring 1 only. Does this make sense?
Yes, sir.
Okay. So we use this many moles of electron to get 1 by 4 moles of O2. And we are going to use the same number of moles of electron for silver also. Now, if you look at this equation, 1 mole of electron, it gives 1 mole of Ag. And how many moles of electron we are using? We are using only 1 mole of electron. And it is going to give 1 mole of Ag. This will be in grams, 108 grams. Okay, 1 mole of Ag, its molar mass has been given 108. That is why we are writing 108. Done, guys? This one official me. Anyone still writing? No one is writing. Try this. A constant current was passed through a solution of AuCl4 negative ion between gold electrodes after a period of 10 minutes. The increase in mass of cathode was 1.314 gram. the total charge passed through the solution is dash Faraday. See, see the reaction that is happening will be AuCl4 है ना minus ध्यान से देखिएगा सवाल को a constant current was passed through a solution of AuCl4 negative between gold electrodes, so the electrode were also of gold. After a period of 10 minutes, the increase in the mass of cathode, the cathode was also what? Gold. So in cathode, what will be depositing? Gold. So AuCl4 say you are going to Au. So what is the change in oxidation state? Here Au will be in 4 and here Au will be in plus 3 oxidation state. Here it will be in 0. So delta OS, it is equal to how much? It is equal to 3. Now, please see. Faraday is equal to how much? Faraday is equal to number of moles multiplied by number of moles multiplied by delta OS. So Faraday will be equal to number of moles is equal to how much? Number of moles is equal to the given mass divided by the molar mass, that is 197. This will be equal to 1.314 divided by 197 multiplied by 3. And you will get the Faraday. Make sense? Yes or no? Please tell me. This is the mass that is deposited. So उसी को number of moles का क्या लिखेंगे? Given mass by molar mass. 1.314 divided by 197. Right. 1.314. This is 3.942 divided by 197. And you have to give in a 10 to the power minus 2. So 197 को डबल करेंगे तो approximately 39 आ जाएगा. I think so. So I can multiply 100 and 100. 394.2 divided by 197 into 10 to the power minus 2, because this 100 I have multiplied, this 100 is still there, and I've converted it into exponents. So I think this is approximately equal to 2. So आपके पास आंसर 2 आना चाहिए. 197 into 2 will be 394, no? 197 into 2. Yes, 394. ठीक है, approximate answer क्या आएगा? 2, and to the nearest integer 2 will be the answer. Anyone still writing? Anyone still writing? No, no one is writing. Try this. अब इसको कीजिए खुद से. The mass of zinc produced by the electrolysis of zinc sulfate solution with a steady current of इतना for इतना minute. This is quite easy. ये बोर्ड्स लेवल का सवाल है बिल्कुल. Take 2 minutes for this and give me the answer in fractions also if possible. 2 मिनट के अंदर फ्रैक्शन भी आ जाए तो काफी है. You got the answers in fraction. Fine. Yeah, is it in nearest integers? Tariq, your answer is not right. Nearest integer में देखिए एक बार. Just confirm it once. It's quite near, but it's not right. So yes, yeah, that is correct now. The mass of zinc produced by the electrolysis of zinc sulfate. Zinc sulfate is ZnSO4. That will give you Zn2 Zn. Huh? This is going to give you zinc. This is plus 2 and this is 0. Delta OS, it is equal to 2. And here you have been given the electricity and the minutes. So I can calculate the coulomb. Coulomb, it is equal to ampere into seconds. Ampere is how much? 0.015 into 15. 15 into seconds will be into 60. So the coulombs will be equal to 0.015 multiplied by 15 multiplied by 60. This will be 13.5. So this many coulombs we are having. Then you will apply the Faraday formula. So Faraday, it is equal to number of moles into delta OS. Okay. Now we have coulombs and we have to convert it into Faraday. That means what we'll have to do, we'll have to divide this by 96500. So you'll get this as 13.5 divided by 96500. It is equal to the mass that is deposited divided by the molar mass, which is number of moles, na 65.4 multiplied by delta OS, that is equal to 2. So the mass deposited will be equal to 13.5 multiplied by 65.4 divided by 96500 into 2. 45 नहीं, 45 से थोड़ा ज्यादा हो रहा होगा शायद. So it's coming as 45.7 into 10 to the power minus 2. So this nearest integer will be 46. So answer will be 46. Make sense, Shahid? Okay. Anyone still writing?
Yes, sir.
Anyone still? So please write it down.
Yes, sir.
Then last two lines. Yad, what are you saying? Oh, you are saying last two lines you try to. Now we have conductance and Colbro's law. Again, theory will be, I will be writing the whatever formulas needed whenever required. Okay, but we'll start with questions itself. Identify the factor from the following that does not affect the electrolytic conductance of a solution. It does not affect the electrolytic conductance. Okay, Shahid has answered. What about others? What about others? No. Fine. See, chलिए. So electrolytic conductance, it depends on the number of ions an electrolyte produces or electrolyte how it dissociates, right? So if I talk about the nature of solvent, you must understand that some things है ना, अगर आपको क्लास का याद हो, for example benzoic acid, it associates in benzene but dissociates in water, ठीक है? So nature of solvent, it does play a role in how the electrolyte is ionizing. So nature of solvent, it does affect, ठीक है? That means it is not the correct option. It is affecting the, it is affecting. We have to look at what is not affecting. No? This is not going to be the answer. The nature of electrolyte added, obviously the nature of electrolyte is also going to affect because strong electrolyte or weak electrolyte. Then we have the nature of electrode, and then we have the concentration of electrolyte. The nature of electrode, it does not affect what? It does not affect the ionization. The ionization of electrolyte, it is not affected by the electrode. Even if you don't have any electrode and if you put something in water and it ionizes, okay? So C is the correct option, that it is not going to affect the, it is not going to affect the electrolytic conductance. What about the concentration of electrolyte? We all know that as we are going to dilute the, as we are going to dilute the solution, more and more electrolytes will be dissociating. Okay, so concentration also plays a role. So option number C is the correct answer. The nature of electrode used does not affect the electrolytic conductance of a solution. All the other things, they are going to affect the electrolytic conductance in a solution. Okay. Next. This is a integer type question. The number of correct statements. Shahid has answered. Take one more minute. D. Tarif, it is not an MCQ. It is an integer type question. You have to tell the number of correct statements. How many of them? How many of these
Okay,
statements are
sir.
correct? Only one is correct. Actually, the first statement is saying that conductivity always decreases with decrease in concentration for both strong and weak electrolytes. What do you guys think? This is true or false? Tell me, guys. True or false? Conductivity. False. What about others? That is also false. Madiha, Maria, Fadil. Maria was saying false. Does anyone remember what is the formula for conductivity? देखिए कंडक्टिविटी जो होती है ना, kappa depends on ions per unit volume. ठीक है. Now if you are going to sigma is A into sigma upon L. See, conductivity is kappa. It depends on the ions per unit volume. Like in 1 unit volume, how much ions you are having. So if you are going to decrease the concentration, ions per unit volume, it is also what going to decrease. That is why conductivity will always decrease when there is a decrease in concentration. ठीक है? नहीं, that is molar conductivity. Yeah, that is molar conductivity. जो आपने लिखा ना K 1000/m, that is molar conductivity, not conductivity. ठीक है? So conductivity, it depends on the ions per unit volume. What is conductivity? If you have an electrodes of 1 centimeter square and the distance between them is 1 centimeter, so this will give you 1 centimeter cube. Now, whatever conductivity is given by this particular cell, it is known as whatever conductance is given by this particular cell is known as conductivity. Okay, so this is 1 unit volume, 1 ml. Fine. So it depends on the number of ions. If you have more number of ions, the conductivity will be more. If you have less number of ions, conductivity will be less. So this statement is true. The number of ions per unit volume that carry current in a solution increases on dilution. Now, this is false because the number of ions per unit volume that carry current, this is talking about what? This is talking about conductivity itself. Okay? Increases on dilution, the number of ions per unit volume. No, it does not increases on dilution, it decreases. Because when you are, if let us suppose the total number of ions we are having is 1000 and the total volume we are having is 1000. So this is the number of ions per unit volume. And if I'm going to increase the volume as 2000 ml, then the per unit part is what it is going to decrease, because 1000/1000 it is equal to what? 1, and 1000/2000 is equal to 2. It is equal to 1/2, that is 0.5. This statement is false. Now the next statement, the molar conductivity increases with decrease in concentration. This is true, because we know that molar conductivity lambda m, it is equal to kappa into 1000 divided by the molarity. So molarity, it increases, decrease in concentration, molarity decreases, and molar conductivity, it increases. The variation in molar conductivity is different for weak electrolyte. This statement is also true because if I am having strong electrolyte, it increases steadily in a linear fashion. And if I have a weak electrolyte, it increases exponentially like this. Okay? So both of these statements are true. And for weak electrolyte, the change in molar conductivity with dilution is due to the decrease in degree of dissociation? No, because as we are diluting, the degree of dissociation, what? It increases. So degree of, with dilution, decrease in degree of dissociation does not happen. This is false. So how many true statements? A, C, and D. These are the three true statements. Please copy this down. Anyone still writing? Anyone still writing? No one is writing. The values of conductivity of some material are given. The number of conductors. See, let us see. Again, this cannot be conductor, make sense because its conductivity is very less. Okay. Then we have 1.10, 3.91, 10 to the power minus. Again, this cannot be a conductor. Then you have 1 into 10 to the power minus 7. This is also what? The conductivity is very less. This cannot be a conductor. So how many remaining? 1, 2, and 3. Yeah, 3 is correct answer. फोर कहाँ से हो गया? 1, 2, 3. This is 1, na? Maria? This is 2, 3.91. 4 is 2.1. Acha, 2.1. हाँ, ठीक. I missed that. I missed that. Sorry. Yeah, this is also a conductor. Fine. GG, Maria. Thank you. 4 will be the correct answer then. So since we are having a bit of time left now, so we will do one question from chemical kinetics, जो कि बचा हुआ सवाल था, ठीक है? This was about this question. Write this. For a reversible reaction A giving B, the delta H forward is 20 kilojoule per mole. The activation energy of uncatalyzed forward reaction is 300 kilojoule per mole. When the reaction is catalyzed, keeping the reactant concentration same, the rate of catalyzed forward reaction at 27 degrees Celsius is found to be same as that of uncatalyzed reaction at 327 degrees Celsius. The activation energy of the catalyzed backward reaction is. Write the question, you have to write it. ठीक है. All of you wrote this question, yes or no, please tell me. Anyone still writing?
No, sir.
No. ठीक, ध्यान से देखिएगा सवाल को, ठीक है? Please stop writing. See this question. For reversible reaction A to B, the delta H forward is 20 kilojoule. 20 kilojoule, that means it is endothermic. The energy of reactant will be lower, energy of product will be higher. That is why ना delta H क्या होता है? Product minus reactant. So this is what delta H, this is 20 kilojoules. First of all, does this make sense? Yes or no, please tell me.
Yes,
जी बताएं. ठीक. Next, they are saying the activation energy of uncatalyzed forward reaction is 300 kilojoule per mole. That means they are saying this part, forward reaction uncatalyzed, this is uncatalyzed, right? This is how much? 300. This is 300 kilojoule because activation energy, not threshold energy. Okay, activation matlab like the reactant, they already have some energy and you have to give some extra energy to reach threshold energy. That is known as activation energy. This is activation energy, 300 kilojoule per mole. When the reaction is catalyzed, keeping the reactant concentration same. So reactant concentration is same. The rate of catalyzed forward reaction at 27 degrees Celsius. So rate, this is at 27 degrees Celsius and it is catalyzed, is found to be same as that of uncatalyzed reaction as at 327 degrees. This reaction, it is at 327 degree and uncatalyzed. Does this make sense? Yes or no, please tell me. Both the rates are equal. The rate of catalyzed forward reaction at 27 degrees Celsius, rate of forward reaction at 27 degrees Celsius is found to be same as that uncatalyzed reaction at 327 degrees Celsius. This makes sense? Yes or no, please tell me. बोले जल्दी बोले. Please don't write now, है ना? Fadil, Maria, Madiha, Shah. Yeah, tell me. Make sense? Yes or no?
Yes, sir.
नहीं. Make
Yes.
sense? ठीक है. So I can write rate as what? I can write rate as the rate constant at 27 degrees Celsius and catalyzed into the concentration of A, which will be equal to the rate constant K at 327 degrees Celsius, and it is uncatalyzed. So I'm not writing uncatalyzed. I'm just writing 327 degrees Celsius into the concentration of A. Now you're seeing that keeping the reactant concentration same, that means concentration of A and concentration of A is same. Make sense? Yes or no, please tell me.
Yes, sir.
ठीक है. Now please see here. We can write K. What is K? K is equal to A into e to the power minus EA upon RT. This is also will be equal to what? A into e to the power minus EA. This is, I will write T1 and T2 है ना? EA upon R T2. Make sense? Yes or no? ठीक है. अब pre exponential factor, it is also going to be same. Now both the E are the bases are same, so I will equate the powers. ठीक है. And once I equate the power, what I will get? This is what? This is catalyzed. Please remember, this is catalyzed. This is 327 and uncatalyzed. Catalyzed and 27 डिग्री सेल्सियस. ठीक है. तो आई विल राइट EA. अब यहाँ पे देखिए इन्होंने कुछ इन्फॉर्मेशन दिया है कैटलाइज्ड रिएक्शन का दिया. अच्छा, अनकैटलाइज्ड का दिया है. ठीक है. इट्स नॉट कैटलाइज्ड, अनकैटलाइज्ड. You have to find the activation of the catalyst ना. ठीक. Minus EA. Rather I can write only EA upon R. T is what? It is 27. 27 के लिए केल्विन कितना हो जाएगा? 300, right? ठीक है. This will be equal to EA. What is the EA for uncatalyzed reaction? Uncatalyzed reaction is the activation energy of uncatalyzed forward reaction is 300 kilojoule per mole. 300 kilojoule मतलब 300 into 10 to the power 3 divided by R into what is T2? The T2 is 327. 327 will be how much? 27 is 300 Kelvin, so 300 more 600. Make sense till here? Yes or no? Please tell me.
Yes,
R
sir.
and R will be cancelled. ठीक है. And EA is equal to 300 into 300 into 10 to the power 3 divided by 600. ठीक. So this will be 2s are, and this will be 150, and this will be what we are having any powers. Oh, kilojoule per mole. ठीक है. We'll be having 150 into 10 to the power 3 kilo. I mean joules per mole, and 10 to the power 3 को अगर convert करेंगे, so this will become 150 kilojoule. ठीक है. This is what? This is the activation energy of forward reaction. ध्यान रखिएगा. ठीक है. This is activation energy of forward reaction. Does this make sense? Yes or no? Please tell me. ये सारा हम लोग फॉरवर्ड कर रहे थे ना. बात समझ आ रही है? See the uncatalyzed forward reaction is 300 kilojoule per mole. तो यहाँ पे जो हमने 300 डाला है, this is the activation energy of what? Uncatalyzed forward reaction. ठीक है. And they're saying when the reaction is catalyzed, keeping the reactant concentration same, the rate of catalyzed forward reaction. So all of these things are what? Forward. Makes sense? Yes or no? क्या ख्याल है? बोलिए guys. What we have calculated till here is the activation energy of the forward reaction. हाँ या ना? बोलो भाई. नहीं. Yes or no guys? Tell me. ठीक है. बट वी हैव टू कैलकुलेट द एक्टिवेशन एनर्जी ऑफ कैटलाइज्ड बैकवर्ड रिएक्शन. यहाँ पे आप देखिए बैकवर्ड रिएक्शन के लिए कैसे कैलकुलेट करेंगे. We have found that this activation energy of what? Activation energy of the forward reaction. This is equal to how much? This is equal to 150. And we know that this delta H, this is equal to how much? 20. Now this is what? Forward reaction, activation energy. I think if I say that this will be what? The activation energy of backward reaction. Does this make sense? Yes or no? This is the activation energy because they are going reactant to product. This is forward. Product to reactant will be backward, and this will be the activation energy of backward reaction. Make sense? Yes or no? Please tell me. बोलते क्यों नहीं है आप लोग? फादल, मारिया, मदीहा, तारीफ, शाहिद, याद.
Yes, sir.
Make sense? ठीक है. So
Yes, sir.
this
Yes, sir.
activation energy will be equal to 150 minus 20. Make sense? This whole thing is 150. This is 20. So this will be 130. So 130 kilojoule per mole will be the answer. Please copy this down. Anyone still writing?
No, 1 minute.
Okay.
Yes, sir.
Sure. So that's it for today. Tomorrow you will be having the test for these chapters: mole concept, solution, chemical kinetics, and electrochemistry. The pattern will be same as that of JEE mains. Okay. So you'll be having 20 questions, which will be MCQ, 10 questions will be numerical time. Out of this 10 questions, you will have to attempt 5. Okay. Actually, so we'll meet day after tomorrow, Saturday. Huh? And what are we going to have on Saturday? Saturday.